So in this video, we are going to be looking at the topic surds, and we're going to be looking at what surds are. And then we're going to look at the different operations that we can perform on surds. Then after that, we can be able to solve a few questions so that they can be able to guide us on how to go about surds. So what is surds? Surds is basically irrational numbers written using the root symbol. For example, the square root of 2 and the square root of 5. So surds, when we take the square root of 2, it's going to be 1.414 for significant figures. This number can be continued. Since it cannot be written as an exact value in decimal form, hence now we write it as root 2, and that is what now we call surd form. And now, there are different ways that you can be able to operate on surds. So for example, if we have got the value root 2 plus root 2. So what we do, we treat these ones as if it's algebra. So we treat this as if it's x plus x. So when you put x plus x together, you're going to get 2 root 2x. And so in this case, when you take root 2 plus root 2, you're going to get 2 root 2. You can also have a scenario whereby you have got 3 root 5. We take away root 5. So this means we're having 3 root 5 take away 1 root 5. So 3x minus 1x is going to give you 2x. So this is going to be simply 2 root 5. So that way, you are performing addition and subtraction on surds. So we can also perform multiplication on surds. So for example, when we have got root 2 multiply root 5, so basically we know that this is the same as having the square root of 2 times 5, which is now going to give us the square root of 10. As simple as that, we have multiplied surds. In case the surd has got a coefficient, we have got 3 root 2 multiplying 6 root 3, like that. So we multiply the coefficients, so 3 times 6, so that we have 18. And then you multiply the ones inside the roots. So we multiply 2 times 3, so that now we have 6. So this will give us 18 root 6. So that way now we'll have done multiplication on surds. Now, we can also be able to simplify surds. For example, for a scenario whereby we have got the square root of 72, we know that 72 can be written as 36 multiplied by 2. And this is equivalent to the square root of 36 multiplied by the square root of 2. So we know the square root of 36 is going to be 6. And now 6 multiplied by root 2 is going to be 6 root 2. Another scenario is when, for example, we have got the square root of 18. So we know very well that 18 is equivalent to 9 multiplied 2, which is equivalent to the square root of 9. And then we multiply by 2. And so consequently, this is going to give us 3 root 2. So when you do that, you have reduced the surd from a bigger number, that is, for example, the square root of 72, to becoming 6 root 2. Another example is the square root of 18 to becoming 3 root 2. So when that happens, you have simplified the surd from a bigger number to a smaller number. Something else that you can be asked to do is to do rationalization of surds. So basically, rationalization of surds is the removing of the root or removing of the surd from the denominator. For example, in a casing point where you have got 1 out of root 5, and then you're told to rationalize, So basically this means we take away the root from the denominator. So in order to do that, we simply multiply by that third in that denominator, but in a fraction, in order to maintain the same value, whatever you do to the denominator, you also do it to the numerator. So we multiply by the same value in the numerator. And so in this case, we are going to have the square root of 5 divided by root 5 times root 5 is going to give us 5. So when we do that, we have rationalized the third. In another scenario, we can have a coefficient. For example, a scenario whereby we have got 3 all over 2 root 2. In a scenario like this one, we can choose to multiply by the coefficient and the third, or we can multiply by the third only. So in order to remove the third from the denominator, so we can multiply by the square root of 2 in the denominator. And whatever you do to the denominator, you also do it to the numerator. So you also do the same. And in this case, you're going to have 3 root 2 now divided by 2 root 2 multiplied by root 2. And so in this case, you're going to have a 4. So that way now, you have rationalized this third. In other scenarios, we are going to have a case in point whereby we have got a third like this one, 3 all over 1 minus root 2. So this third has got two parts, that is 1 and take away the root 2. So in this scenario, what you do, we develop something we call a conjugate. A conjugate is basically the opposite of the third, which is now, we just change the sign at the middle. So the conjugate of 1 minus root 2 is 1 plus root 2. So you multiply by the conjugate in the denominator. And again, whatever you do to the denominator, you also do it in the numerator. So you also do the same there. And so here, you're going to work out so that in the numerator, you're going to have 3 plus 3 root 2. And then in the denominator, you realize that from binomial identities, here you're having a difference of 2 squares. So you're going to have 1 squared, take away root 2 squared, which is 2. And so when you do that, you're going to have 3 plus 3 root 2 divided by negative 1, which is going to give you negative 3. You take away 3 root 2. So when you do that, you have removed the third from the denominator. And so here we say that you have done rationalization of surds. So in this question, we are told that we simplify the following surds, leaving your answer in the form a plus b root c. And so basically here, in this case, we take the two parts of the surds as if they're two fractions, and then we put them together by addition. So to put them together by addition, we look for the LCM. And so in order to get the LCM, we are going to find the product of the denominators. And the product of this denominator is going to be 2 root 2. And then we take away root 5. And then you multiply that with, again, 2 root 2. And then you add that to root 5. And now for the numerator, we are just going to get the denominator, the product of the two, divided by the denominator, for example, for the first part with the first denominator. So that's in the numerator, we're going to have the square root of 5 multiplied by 2 root 2, and then plus the square root of 5. And then for the second part, we are going to have the square root of 2, and then we put in brackets 2 root 2, and then we take away the square root of 5, like that. And now here, so that you can be able to work out for the numerator, we open up the brackets, and then after opening up the brackets, we put the like terms together. So for example, for the first one, we take root 5 multiplied by 2 root 2. So that's then we're going to have 2 root 10. And then we take root 5 multiplied by root 5. And then now we're going to have 5. And then we also now take, for the second bracket, root 2 multiplied by 2 root 2. So here, so that you can be able to multiply, you multiply root 2 by root 2, so that you get a 2. And then that 2 you multiply by these 2 that is outside, so that you get a 4. And then now you take away root 2 times root 5, which will give you root 10, like that. And then all these, we divide by the product of these two. So when we look at these two, we know that this is a difference of two squares, where we have got a plus b multiplying a minus b. And we know when this happens, we are going to have a squared, we take away b squared. And so in this case, we are going to have 2 root 2 squared, and then we take away the square root of 5 squared. So there we use our knowledge on binomial identities so that you can be able to simplify that. And so here when we work out, we put the like terms together in the numerator. 2 root 10, we take away root 10, it's going to give us 1 root 10. And then we go to 5 plus 4, so that gives us a 9. And then all these we divide by 2 root 2 squared, which gives us 8, and root 5 squared, which gives us 5. So 8 minus 5 is going to give us 3. And so consequently, if we separate this, we are going to have 9 divided by 3, and then plus square root of 10 divided by 3, which is going to be equivalent to 3, and then plus another root 10. And so this way now, we have written our answer in the format a plus b root c. So here in our second question, we are told, simplify and rationalize the expression, giving your answer in the form a plus b root c, where a, b, and c are constants. So as we did in the first question, first of all, we get the LCM of the two denominators, where it's the product of the two. So we take 7 minus root 3 multiplied by 7 plus root 3, like that. And then now, in the numerator, we're going to take our LCM, divide by 7 minus root 3. So that will be left with now 11 multiplying 7 plus root 3. And then now we take away, in the other part of the numerator, we are going to have now 5 multiplying 7 minus root 3, like that. And then now we work out the numerator part, and we also put the like terms together. Then we go to the denominator, we simplify. So in the numerator, we start by multiplying the first bracket. 11 times 7 is going to give us 77. And then plus 11 times root 3 is going to give us 11 root 3. And then we take away the second bracket is going to be 5 times 7, which is going to give us 35 negative. And then negative 5 multiplied by negative root 3 is going to give us positive 5 root 3. Then all this we divide by, again, when you look at our denominator, this is a product of, this is a difference of two squares. So since it's a difference of two squares, we take 7 squared, which gives us 49. And then we take away the square root of 3 squared, which is going to give us still a 3. And then now we can put the like terms together in the numerator. So when we put the like terms together, we get 77. Take away 35 is going to give you 42. And then you take 11 root 3 plus 5 root 3 is going to give you positive 16 root 3. And then 49, you take away 3, is simply going to give you 46. And then now after that, we can separate the two so that we have 42 out of 46, and then plus 16 out of 46 root 3. Then we cannot leave our answer like that. We have to simplify. And so when we simplify here by 2, we're going to get 21 out of 23. And then here, the second bit, when we simplify by 2, we are going to have 8 out of 23 multiplying root 3. So we leave our answer in the format A plus B root C. Now that question, we are told to express in third form and simplify by rationalizing the denominator. 1 plus cos 690 divided by 1 minus sine 60. So here we've not been given the surds, and we have been given the angles, whereby the angles, the cos and the sine, are going to be in third form. So first, we need to remind ourselves about the special angles that we learned in trigonometry, and also we need to remember the unit circle, so that now we can be able to substitute appropriately. So first of all, we remind ourselves about the special angles 60 degrees and 30 degrees. So we have the sine of 30 degrees, which is equal to half. We have the cos 30 degrees, which is equal to square root of 3 all over 2. And also we have the tan of 30 degrees, which is equal to 1 out of root 3. Then we have the sine of 60. Sine of 60 is going to be equivalent to the cos of 30, since both are complementary, or they add up to 90 degrees. So here we're going to have the sine of 60 as the square root of 3 all over 2. And then we can have the cos of 60, which is going to be a half. And then we can have the tan of 60, which is going to be the reciprocal of the tan of 30, which is root 3. So basically, we know this, and then now we know the unit circle, so we can be able to tell each of these angles where they're going to be located. So in our unit circle, we normally say that all trigonometric ratios in the first quadrant are going to be positive. Only sine in the second quadrant is going to be positive. Only tan in the third quadrant is going to be positive, and only cos in the fourth quadrant is going to be positive. So we just need to find out where our angle, for example, 690, in which quadrant is it in. So when we check, the angle 690 is going to be in the fourth quadrant, meaning that its cosine is going to be positive. And the angle 690 carries the acute angle 30 degrees. And so the trigonometric ratio cos 30 is going to be the same as the cosine of 690. So we simply substitute, and in the numerator, we are going to have 1 plus the square root of 3 all over 2. All this is going to be divided by 1 minus the sine of 60, and the sine of 60 is root 3 all over 2. And now here, for us to be able to rationalize, we multiply the denominator by its conjugate. So the conjugate of 1 minus root 3 all over 2 is going to be 1 plus root 3 all over 2. And whatever you do to the denominator, it must also be done to the numerator. So we also multiply the numerator by 1 plus root 3 all over 2, like that. So simply here, you go ahead and work out. In the numerator, you can see that there you're having a product of 2 squares. And so basically, when you multiply these two, you're going to have 1, and then plus root 3, and then plus 3/4. And all this is going to be divided by, when you look at these two again, that is a difference of two squares. And so in this case, since it is a difference of two squares, we are going to have 1, and then you take away 3/4. And now, after that, you put the like terms together. In the numerator, you're going to have 1 plus 3 all over 4, which is going to give you 7 over 4, and then plus root 3. And all this is going to be divided by 1 minus 3/4, which is going to give us a quarter. So 7 over 4 plus root 3 divided by a quarter is the same as having 7 over 4 plus root 3 multiplied by the reciprocal of a quarter, which is 4. And so when you multiply this, we are going to have 7 plus 4 root 3. So this is going to be our expression being simplified to the simplest form. So in our last question, we have been told that without using a calculator or mathematical tables, simplify completely, leaving your answer in the form a plus b root c, 1 minus cos 420 degrees divided by 1 plus tan negative 330 degrees, and you'll be given 3 marks. So this question is similar to the previous question, whereby you, instead of being given surds, you've been given angles whose trigonometric ratios are going to be surds. So we also need to apply the same content about the trigonometric ratios of the special angles. So we just need to ask ourselves, for example, when you look at 420, which acute angle does 420 carry? So we know that 420 carries the acute angle 60 degrees. And now 420, we ask ourselves, in which quadrant is it going to be? 420, we know, is going to be in the first quadrant. So since 420 is in the first quadrant, it means all its trigonometric ratios are also positive. Then we also look at negative 330 degrees. When we look at negative 330 degrees, we ask ourselves, which acute angle does it carry? So we know negative 330 carries the acute angle 30 degrees. And negative 330 is in the first quadrant also, meaning that all its trigonometric ratios are also going to be positive. So here we simply substitute. So we are going to take now 1, take away the cosine of 420, which is similar to the cosine of 60 degrees. And we know the cosine of 60 degrees is a half. And then in the denominator, we are going to have 1 plus the tan of negative 330, whereby the tan of negative 330 is going to be the same as the tan of 30 degrees. And we know that the tan of 30 degrees is going to be 1 all over root 3. And so in this case, we have rewritten our expression now in form of a surd. So we work out, and we know here in the numerator, when you put those two like terms together, we are going to have a half divided by 1 plus 1 all over root 3. So in order to simplify the surd, we multiply by the conjugate of the denominator. So we multiply here by 1, take away 1 all over the square root of 3. And whatever you do to the denominator, you also do it to the numerator. And so in this case now, you can simply just work out the numerator so that you have half, and then take away 1 all over 2 root 3. Then all this we divide by, when we multiply these two, and then we know we have a difference of 2 squares in the denominator. And so when we work out, we are going to have 1, we take away a third. And so consequently, here we're going to have a half, take away 1 all over 2 root 3, divided by 2 thirds. And when this happens, we know this is equivalent to having a half, take away 1 all over 2 root 3. So we multiply by the reciprocal of 2 thirds, which is 3 out of 2. And so when we multiply, inside the brackets, we are now going to have 3/4, and then we take away 3 all over 4 root 3. But now 3 all over 4 root 3, we cannot leave it like that. So we have to remove the surd. So we multiply by root 3 for this part. And whatever you do to that denominator, you also do it to the numerator. And so consequently, we are going to have 3/4. And then we take away, now when we work out here, we are going to have the square root of 3 all over 4. And that way now, we shall have simplified our expression in the form a plus b root c.